Yeah, welcome to class 3. Today is probably the most hands-on session we have had so far. Today will be like a lot of hands-on. We are going to build one real end-to-end machine learning project together from scratch in the over next 3 hours. So here most of you will have a doubt that project, why we are doing a project all of a sudden in the beginning of the class and not at the end. And isn't it beginner friendly, and shouldn't we learning about machine learning problems first and then dive into a project? That's a classic question. So why I have turning this project, I'm turning this class into a project is because uh, it has messy and real world data. I mean, whatever the project that we are going to take up now, the Titanic survival prediction, it has a very messy real world data. So working on missing values, mixed data types, categorical columns, everything that you will encounter in this particular project that we are going to do, you will be encountering them in your actual job. So instead of me just reading out, explaining the concepts virtually, I thought of redoing the entire presentation that I have had here into a project. So while doing a project, you will be learning the concepts that are in ML, like handling the missing values, converting, categorical variables into numerical. So you will be learning all these kinds of conceptual stuff to a by a live project. So that was the goal of this session. Instead of teaching data preparation as a list of isolated techniques, we are going to discover each technique naturally as we are trying to make a model work in this particular class. By end of this class, you will have a working notebook, I mean the Google Colab. You can reuse on any tabular data set like customer churn, credit scoring, loan approval. You have to just swap the data. So the entire purpose of this project is we will be working on Titanic survival prediction, but you will be able to convert the project into any of the project of your liking. Just you have to change the data. The code remains the same. I mean, the columns have to match. The code remains the same. The technique remains the same. The entire structure remains the same. All you have to do is you can put any data you like, any data set you like, and you have to just change the column names here and there, and we will be good. Uh, just a quick check. Have any of you heard about Titanic survival before? Like the dataset, Titanic survival dataset before? I just want to know.
No, I haven't.
Okay. So then let's first talk about Titanic survival dataset. And for any dataset that you see in this particular course, I go to Kaggle or I go to Hugging Face. These are the two main places I go for my datasets. Since Titanic survival is so famous, it is available in Pandas library. Like in last week project, like how I have shown that a particular dataset is already available in Pandas library. The same way, Titanic survival is also a dataset that is already available in Pandas library. But let's just see that. So here you can see the data set, like it has passenger ID, survived, P class, name, sex, age, so and so. There are total 12 columns in it. You can see the standard deviations and all. So using this particular data set of what we have, we are going to find out on what conditions whether a person is going to survive the Titanic. That is what our entire model is based on. So that when there is a new ship or a boat that is similar to Titanic, we can take the passengers based on this data. Even if any major calamity happens, we have to know that this person is going to survive for sure. Something like that. I'm just making up all the things. It need to be a real business scenario. I'm just making up all the things, but yeah, that is what this data set about. And why I specifically picked these data sets from all of the other data sets is it is widely used data set. It has a lot of messy data, and as a beginners, this data set teaches a lot. It has a lot of mistakes, it has a lot of miscalculations in it, so that helps us to make us mistakes, and from that mistakes we are going to learn. You no need to download this dataset, because since it is already there in Pandas, we are going to write the code to automatically fetch it. If you are working on any other datasets, like for example, uh, any specific datasets that a particular specific user have created, let's take something like the complete Titanic dataset, maybe by Barbosa. If you want to use this particular dataset, then you go and download this particular file, or else for this particular project we no need to download, it comes from Pandas. Yeah, why this data prep matters more than the model. So what is this data preparation? Before diving into any project, any model creation, anything that is related to machine learning, or not even related to machine learning, but even if you want to find something, let's say there are you're working on a voting commission, you're a person in a voting commission, and there are 10,000 people from a particular community has given the votes. Now you want to find out how many male have voted, how many female have voted, and how many people who are exactly turned 18 this year and they have voted. So you want to get all this kind of normal data which doesn't require any kind of machine learning. And for this kind of data also, data preparation matters a lot. Why? Because if your data is messy, if your data has some mistakes in it, automatically your output becomes messy and your output will have a lot of mistakes in it. Classical example is, for example, if you take a count of number of male or a number of female from a particular area, if the count is coming in decimals or a float, then obviously it says that something has gone wrong, because the count of people from any particular region cannot be in a decimal format. I mean, cannot be 2.3, cannot be 2.5 in decimals. It can be 2.0, which is okay, but it cannot be 2.1 and 2.2. That doesn't see any count of anything. So that is one of a classical example. uh, so continuous variables cannot be for some of the columns, like age, or age also. Age is one more example. You cannot be an age of 2.3 or 2.6. That is not how we communicate. We say it's like my age is 23 or 26. It has to be in a integer format, a correct integer format, not like a decimal format. So in real world, data is always messy, because people tend to make mistakes. There will be missing rows, missing columns, there will be missing age, inconsistent types. Like for example, if you give a form to fill in a survey, like for example, in the age place they can keep their software engineer. Like for example, the label says age, and some people, without even reading, they may keep something string value, like a software engineer or their occupation or something. So humans tend to make mistakes, and that is natural. As a data engineer, first you have to take care of the data. First you have to become a proper data engineer, then you will be becoming a machine learning engineer. So becoming a data engineering should be your first goal. That is your first step. So missing age, inconsistent types, sparse columns, all these are classical examples of real world data being very wrong. And most machine learning projects, they have to go through a certain phase where you will be cleaning the data, where you will be tuning the model, which will be coming later. So you have to do all these kind of things before you start an actual project. And yeah, so talking about this particular data set, the Titanic data set, Um, the Titanic dataset is a perfect demonstration of again this real world messiness. The age column, I mean that you will see the data in a while when we start the code part. The age column will be missing 20% of passengers. The cabin column is almost entirely empty. We have a mix of numbers and text categories in the dataset. Some passengers have missing embarkation port as well. I mean, where they are going to deport. Those things also will be missing. And I'm going to teach you how to handle all this kind of data in a very efficient way. So our job today is to handle all that systematically. So the model gets clean, consistent input every single time, whether during training or when predicting new passengers. This is what I was teaching you in class 1 in class 1. Like I was saying, like if the trainings, I mean if you are not giving training properly to a child who is just learning about this world, the output also will be wrong. Whatever you teach, it gets reflected back. So if your training data set is bad, your output data set is also will be bad. So you have to make sure your training data set will be on the point. It should not be too good. I'll tell you when when going on the project. I'll tell you what happens. If your training data set is too good, too smooth, it will be a problem. If your training data set is too bad, it will be a problem. You have to act in the middle phase where it is not too bad or too good. That was the thing I was teaching about underfitting and overfitting. A related example you can think of. So yeah, let's go to the next. Yeah, till here, any doubts, anyone? Like what we are going to do in this session? Again, I'm just repeating myself. We are going to do a project on Titanic survival prediction. We are going to get a data on every individual, their age, their relationship, something. We are going to get some data, and from the data, we are going to make a prediction whether the particular individual will be surviving the Titanic or not. Okay. So let me show you the roadmap for today. So you know exactly where we are going. We have roughly 9 steps here, and every single one of them is done on the Titanic dataset. And whatever the roadmap that I'm showing you here is the exact roadmap for any project you do in ML, not only for Titanic dataset, any dataset. It can be for cancer prediction, it can be for marks prediction, it can be for linear regression models predictions, it can be for any ML project you take. If you want your ML project to be very good, you have to follow this 9-step roadmap. So I'll just go through the roadmap quickly. We will be following all of this in our today's class. So first one is we will be getting the data into Colab. How you will be getting the data is up to you. There is one classic function called fetch OpenML which we are going to use today. Either you can use that, either you can download the CSV from Kaggle. You can go to kaggle.com and you can click on this download button, and you can re-upload back it to Google Colab. That is one way. You can also use a Google Drive mount, which means your dataset will be already in your Google Drive, and from that Google Drive you will be mounting it to your project. There are different ways. I'm saying that there are different ways to get your data. When you go into a company, when you're working as a data engineer or an ML engineer, you will be getting the data from a pipeline. So there are different ways to get the data, but the first step always is to get the data into the thing that you will be working on. You may be working in Colab, you may be working in Jupyter Notebook, you may be working in some AWS, you may be working in some Azure. It can be any environment, it doesn't matter, but you have to get your data into that particular environment. That was the first step. The second step is to explore and inspect what you are working with. You have to take a good amount of time to understand your data. I think you have to spend a lot of time in it, because the more valuable time you spend in step 2, makes remaining steps much more easier to do. If you rush in step 2, from step 3 to step 9, it becomes so difficult for you to work on, because you have to understand with what you are working on, what kind of columns you have, what kind of variables you have, what kind of rows you have, what kind of data you have, how much of the data is good, how much of the data is bad, how much of data is a guess, what are the missing values, what are non-missing values, how many integers, how many floats, how many strings, how many decimals, what are the data types, what you can do with those data types, are there matching with real world scenarios. There are lot of questions that can be explored in step 2. If anyone asks me what is the hardest, okay, I'll ask this question at the end. So step 3 is to choose which features to use. Step 3 is to choose, I did not write it here, but I'll send it to you separately in the group. The third step is choose which features to use. In the sense, you will have, let's say, 20 columns in a data set. In an Excel data set, you may have 20 columns, and you're trying to find age of a person. You're trying to find the age of a person. To find the age of a person, date of birth is more than enough. It is more than enough to calculate an age of a person. So you have to put your mind there, and you have to think and select for your particular question, for your particular use case, what are the columns that are important, and you have to list out those columns, and you have to, don't think of the other columns which are not required. You have to choose the features. That is called features. The important columns in ML language, we call them as features. Features, features. So you have to choose which features to use in your particular project or in your model, to train your model. And the fourth step is splitting into training and test sets. This is what we have done in the last class also. And splitting the training and test sets is another important part, because if you don't split your training and test data properly, again that will completely make your model go wrong. And I will explain why the order of this matters as well, because one of my student in one of the batch, he asked me like, Monish, why can't we do step 1, then go to step 3, step 4, then explore the data? There will be a huge mistake happening if you reorder the steps, but which I'll tell you later when I start the code part. I'll tell you. So till now we have covered 4 steps. Get the data into Colab, explore and inspect what we are working with, choose which features to use, split into training and test sets. 4 steps have been covered so far. Fifth step is handle missing values with imputation. Handle missing values with imputation. What is this handling missing values? So as I said, there will be a lot of missing values in the data. You have to handle it. You have to know how to cover it up. If you don't cover it up, your output will be going wrong. So you have to use some or the other kind of methods or techniques to handle your missing values. Step number 6. You will be building pre-processing pipelines using scikit-learn. Usually, if you see any of other videos, or if you go to any of the other courses or something like that, most of the people that I've seen, they are missing step 6. They never teach you, they never talk about how important it is to build a pre-processing pipeline. Building pre-processing pipelines using scikit-learn will make your coding much more simpler. It automates a lot of things. I'm gonna talk about it again in the code part. So remember this this step 6, building pre-processing pipelines using scikit-learn. If you are doing this 6th step right, your entire project becomes much more simpler to code. Step number 7. Here we engineer a new feature from the domain knowledge. Again, step 7 is completely optional, but I always recommend to every student of mine to do step 7. But this is an optional thing. Why? Because from whatever the columns you already have, I recommend everyone to create one more column from the remaining columns, which will be useful for your model. So you already have three important columns. From those three important columns, do something. Use your mind, use real world skills and real world scenarios, and try to come up with an extra column to train your model, which will be a combination of all the features that we have seen in the dataset. And the next step is training the model, evaluating it, and making the predictions. That is step number 8. After you making everything ready, you will be submitting all of this to the model. That is your child. That is the child. I mean a human child. Then the human child starts to process the entire data, and you will be making some predictions. That is your step 8. And finally, uh, step 9 is to just export the entire model, so that you will be using for some other use cases. So these are all the 9 steps. Out of all these 9 steps, only step 8 is actual model training. If you look at it properly, only step 8 is where we are training the model. All the rest of the remaining steps, we are not even touching the model. We are not even touching it. Only one step is for more training the model. The remaining all is for preparation and executions. Only 8 is the actual model training. So here I just want to ask you a question just to see. First of all, before asking the question, did you all understood the 9 steps? Like, did you get a gist of the 9 steps? Or any doubt in any of the step or anywhere? Any doubts in the 9 steps? These are the 9 steps that I was talking about. Oh boy. Why is this turning green? Yep, I think you can see it better now. Yep. So these are the 9 steps I'm talking about. And this should be exporting. Any doubts, anyone? Okay. Yep. Okay, then let's open Google Colab and let us start doing it. have put the Google Colab link in the chat so that whenever I do write the code, it will be automatically updated on your side. Yeah, and please let me know. I mean, you can also do a DM if you have any doubts, if you not feel like asking here. Okay then. So we have our Google Colab here. I already told you in the previous class like why we are going with Google Colab and not with other environments or Jupyter notebooks. And I also told you the first thing that you have to do after opening Google Colab, click on the runtime, go to change runtime type, and here instead of CPU, select GPU. Instead of CPU, select GPU. And right now, I mean, in this class, we are not going to do a lot of ML, like a very deep ML algorithms and all. So that would be fine, like using CPU. But it's a very good habit to change your runtime to GPU as it is always free. So yeah, whenever you do the code right, it won't get stuck when if you use proper runtime. Okay. So the first step. Let's talk about the first step. How to get data into Colab. So basically you can upload CSV. How do I upload CSV? Here on the left hand side you will have a folder option. Connecting to a runtime. Okay, let's wait. It is connecting to the runtime. It's still connecting to T4. Yeah. So on the left hand side, if you click on this files, you will see this, and in here you can click on this upload button, and you can upload your CSV file or a Excel SX file, anything, any file you can think of, you can upload it here and you can bring it here. That is one way to do it. Second is you can mount your Google Drive. Here you can click on mount drive and automatically your Google Drive will be connected to your project. And if you have your dataset in your Google Drive, you can simply bring it here and you can use it. These are like two ways. The third way is downloading via the code. So there are few ways like this wget request kaggle API and all. You can also use this kind of functions, and you can download the code from anywhere. Code in the sense, I mean it's dataset, not the actual Python code, but the actual dataset. You can get the datasets from using request kaggle API or wget and all. And the next one is you can use scikit-learn datasets, that is fetch OpenML. Fetch OpenML. So as I said, Titanic survival dataset is a very popular dataset, and it is already present in your sklearn, your scikit-learn. In the last class we have seen, right? In scikit-learn datasets, it's already there, and we are going to just use it. Manish, how do you know that Titanic is already there in scikit-learn? In the last class, as I shown you, you can go to scikit-learn's actual documentation site. Mm, where is the datasets? Let me search like this. Titanic dataset. I'm just trying to find out from where I've seen in the documentation. Okay, I'll show you from the code. That will help maybe. But yeah, we will be using fetch OpenML. We will be using this fetch OpenML function to call this Titanic dataset from this scikit-learn, and it will be automatically loaded into your project. Or else, if you are not sure, let's say, Monesh, I'm not sure about this scikit-learn and I don't know that this Titanic exists in scikit-learn and all, you can simply go to Kaggle, download the datasets and just upload it back to Google Colab. That also works. Let me show you in a simple way how to do it. You go to Titanic survival datasets, any datasets you like, click on this download, sign in with your Google and all. Just a second. Yeah. So you click on the download. It gets downloaded to your desktop or anywhere. Hit save. It is downloaded. Now go back to your Google Colab. Click on the upload. Go to your desktop. Search for Titanic. Yeah. And titanic.csv is uploaded. This is one way to do it. If you are not sure whether the dataset is already there in any of the scikit-learns and all, you can just simply use Kaggle to download and upload it. Yeah. So today we will be using fetch OpenML because this is the easiest way if we're working on popular datasets. You can simply just get the dataset immediately. Okay, let's load it then. Here I have already given the code. Again, all the libraries are already installed in your Google Colab, so you no need to do pip install pandas, pip install scikit-learn and all. You can simply start writing the code from sklearn. Sklearn means scikit-learn dot data sets import fetch OpenML. And you also need pandas. Okay. Okay. So how this fetch OpenML works? Unlike your normal data downloading and uploading it to your Google Colab, your fetch OpenML automatically gets the data set into capital X and small y. That is your feature matrix and your target. In the last class, I have explained you, right? What is capital X mean and what is small y mean. So automatically your data will be segregated as feature matrix and the target value, capital X, comma y. In the beginning, even I used to have a lot of doubt on what is this capital X and small y, and when during the data fetching. Let me make that clear. If you have few columns in your data set, let's say like student data set, student ID. Now you have to answer me this: student ID, student name, student gender, student age, student hours studied, student uh, marks, maybe marks, or instead of marks, let's say result. That makes sense, result. Now, as a principal, I asked my teacher to create a model so that I have to predict, listen carefully, I have to predict whether the student passes or fails the exam. This is the model I asked my teacher to create. Now, what does capital X and small y mean in this particular data set is small y always represents the prediction value. It always represents the prediction value, or you can simply call it as the targeted value. So in this column, in these all columns, if the principal asks the teacher to create a model that will find the output, I mean whether the student passes or fails in the exam, in the upcoming exam, what should I consider as the target? Any guess, anyone? What will be my target in these columns? Any guesses?
Result.
Results, yes, exactly. So result becomes your small y. If you filter out the result, the remaining all becomes your x. Blindly it becomes your x. That's it. That is what capital X and small y represents when you're importing a data. When you're getting the data for the first time, your y will be always be your prediction value. Except the prediction value, whatever you have, everything becomes capital X. So these all are capital X. This only result column is small y. That's all. Remember this part. Whenever you're getting the data for the first time, your target column becomes your small y. Except your target column, whatever you have. You may have 100 columns, 1000 columns, it doesn't matter. Your small y will be always 1. If you are predicting only one value, it will be only one column. If you are predicting two values, it will be 2 columns. Whatever you are predicting, whatever you are targeting will be your y. Whatever you are not targeting will become your capital X. So your data when importing will be your capital X and small y. That is how fetch OpenML works. Fetch OpenML will automatically segregate the data for you and it gives you capital X and small y. So here fetch OpenML, and here you have to mention what is the data set name that you are trying to import. Here I am trying to get Titanic. I mean, since I already know that it exists in from fetch OpenML, I know the name of it is Titanic, or else we can just search it up in internet, a simple search. There are multiple versions for this particular Titanic dataset. There are lots and lots of versions, but I am going to pick the version 1. You cannot also give all of this. It's not required, but I'm specifically taking version 1 because version 1 contains a lot of messy data. So that is the reason I'm specifically picking up version equal to 1. And you can see about what each parameter does in the neat dialog box that is given here. You can see a version, interactive, default active version of the dataset. So what version of the dataset that you are interested in. And not only that, there are a lot of useful parameters. One of them is as frame. There is as frame. Yeah, as frame. So what is this as frame? If you put the as frame parameter to be true, the data will be formatted into a pandas data frame, including all the columns in D types. So if you want it in a neat pandas data framed version of the data set, then you use that then you use as frame to be true. If you don't use as frame to be true, it will not be a data frame. If you want to automatically convert your data into a data frame, use as frame equal to true, else false. And one more important feature is, one important parameter is return x and y. If you put return capital X and small y, automatically the target will be selected, as your target column will be selected, and the remaining columns will be going to your capital X. If you put it as false, then all the columns will be getting to you normally, and you have to segregate them. You have to again create a small y, and you have to create a capital X, and you have to segregate them separately. What I usually suggest is put as frame equal to true, because it makes things easier. Anyways, you will be doing all of this. You will be converting your data to data frame, and you will be converting your normal data set into capital X and small y. So instead of again writing lot of code, you can just complete it in one single line. So as frame to be true, and return your capital X and small y to be true. That will work. Okay, Monish, you are saying that now we are getting capital X and small y. Now what to do with it? We will be printing it. We will be printing to check the values. Print Yeah, so you can see here that successfully the Titanic dataset is being fetched, and you can see it has 1309 rows, 13 columns, and the target shape is 1309 comma nothing. When I told you in the last class itself, whenever you see 1309 comma nothing, it means 1. It means only 1. There is one column and 1309 rows. So in what this output tells you is, take this example. So this result column has 1309 columns. 1309 columns. That is what this line says. Target shape 1309 comma nothing means one column and 1309 rows in that particular column. Next, feature matrix shape 1309 comma 13 represents whatever the remaining columns you have, that are the non-targeted columns. There are 13 of them, columns. There are 13 columns and there are 1309 rows. Now, if any one of you giving interviews, in my very first interview that happened on ML related, I was asked a question that if my feature matrix shape has some shape like let's say 860 comma 21, 860 comma 21. This was one of the actual question asked to me during an interview. The interviewer asked me, like, if my feature matrix shape is something like 860 comma 21. These numbers I forgot, but I remembered the question, but I forgot the quantity, I mean the number here. I'm just making up the numbers. And he asked me like target, right? Yeah, the target matrix shape equals to something like 560 comma 11 or 560 comma 1. Let's say only 1, 560 comma 1. Now the question he asked me is whether this kind of data is normal, is it a good data, or what do you think of this data, and can we make a model on it, and all. These are the follow-up questions on this particular question. The simple answer is this is not a proper data in the first place. You should not consider this kind of data in the first place. Why? Because the left side number in the shape should always match for feature and target. If it is not matching, do something to match first, but don't leave it without matching and all. For example, here the number of rows for all of these columns should match with the rows that are present also in this column. Then only you will get a proper data set. Then only you can work on a proper model. If your rows are not matching for feature and target, then and there itself there is a problem with the data. You have to make sure to correct the data first. So that was my answer, and yeah, there are a few more questions asked in it, and finally I made the interview. But yeah, that this was one of the basic question people ask to just test your knowledge on ML, on data preparation and data cleaning, because this is a very basic question, whether if the shape's left side value, like the 1309 1309, the rows should match or not match in a data for feature and target. It should always match, and if it is not matching, do something to match it. Then only go and work on the model. Otherwise, don't work on the model. Don't even start the code part. Don't even start the data cleaning part. First, you have to do something to match it. Put NaN, put null values, but you have to match them. If you don't match them, don't even start the project. That is the first thing you have to keep in mind. This will be a very basic question asked to you just to test your knowledge on very basic level. This is very basic level question. 1309 1309 should match for both the capital X and small y. The right hand side, it matches or doesn't matches, not a problem. It should not match actually, but the left side value should always match. The row should always match. Okay, now Monish, let's go here. Monish, from all the steps, get the data into Colab is done. You have successfully got the data. You have successfully got the data and you got the shape of the data. Now what is the second step? The second step is to explore. You have to explore the data now. There is no one way to explore the data, because exploring the data is a very individual thing, is what I feel. Let me get some water. Yeah, sir. So yeah, what I'm saying is exploring the data is a very individual thing. When you are in this class, in this course, I will teach you few things that I use to explore the data. You go to somewhere else, go to somewhere course or something, they will teach you in a different way, but the concepts remain the same, because there is no single way that anyone can teach you. You have to explore the data only in this way. If someone says that you have to only do in this particular way, don't listen to them in the first place. You should not stick to a particular rule when exploring the data. You have to use your own brain, use your own consciousness to explore the data. So let me do some of the things that I normally do to explore the data. The first one I do is capital X dot head. This helps me in getting the overall view on the data, like what are the columns I have. Like I have P class, names, XH, SIBSP, patch, ticket, fare, cabin, embark, board, body, something. Yeah. So you will have a good idea on what the data will look like. If you do x dot head, and x dot head will give you the top 5 rows of data, top five rows of data. You can count 1, 2, 3, 4, and 5. Top 5 rows of data. Next, after getting a good view on the data, like what are the columns, what are the values look like and all, I do x dot capital X dot info. Monish, what is this capital X dot info? Why are you doing it? When you're doing this info, right, you will be able to see what is the column, whether the column has any non-null values or null values, what are the data types in it, and how many of the values are non-null. For example, let's take age. Out of 1309, only 1046 are non-null. You're getting my point, right? Out of 1309, only 1046 are non-null, which represents the remaining value, that is 1309 minus 1046, whatever the number is, that will have null values. So here, that is what I'm saying in the beginning. There will be 20% of values in the age that are empty, and I will show you how to correct it. So age has null values. Cabin, oh my god, cabin has a lot of null values. Non-null are only 295. So there are a lot of null values for cabin. You have to correct it. So yeah, there are few things that have null values, and we will be correcting it later. And also, you can see each data type, like p class is integer, name is object, sex is category, age is float. Like this, you can see, you can segregate each column into different data type. And if you notice a few things, some columns are object type. Monish, what is an object, Monish? In the last class, you said string, text, integer, float, but suddenly what is this object? Objects are nothing but they are text or categorical values. They are text. They simply mean text. Your string values. So that is your columns. And some are float 64, which means decimals. I mean, sorry, numeric. Numeric, but with the decimal values like dots. Age has float 64, which concerns me a bit. Because age should be a proper int 64. It should not be a float 64. So that is a bit concerning, and we'll be changing it in the code. And the non-null count column tells us how many rows have a value. If it's less than 1309, obviously there are missing values. Okay. So before moving forward, any doubts till here? And it's updating, right? Whenever I'm writing the code, is it updating for you? Could you please check in the link that I've shared? It's here, this one. If it is not updating, please let me know. I'll do something about it.
It's updating, Monish.
Yeah.
It's
Okay. Thank you. So I feel like there are no doubts, but if anyone have anything, please let me know, because class 1 is very basic. Class 2, I introduced a bit of difficulty. Class 3, that is today's class, the difficulty is going to be like a linear. So every class from now on, the difficulty level goes on increasing. There will be a class when I am talking about a proper ML algorithms. I think tomorrow or in the next week, there the difficulty will be exponential, not linear. So at a time you will see a rise in the difficulty in machine learning if you are not following properly or something like that. So yeah, if any doubts or anything, please let me know, because the more you be better at the basics, the more you will be better at the upcoming stuff. So So that is your x.info, x.head. There are a lot of methods. There are hundreds and hundreds of methods to follow, but I simply don't go that extent. I simply do x.head so to get a overview on the values on how they look. Then I do x.info to get the overview on the data types, non-nulls, counts and all. Actually, I have to show you a cleaner count. I included that in the slide as well, maybe. Yeah, inspecting the missing values. So this step is completed. Loading the Titanic dataset is completed. We have done the x.head and x.info. Now our next step is to inspect the missing values. So to inspect the missing values, here you can see the count. I mean, here you can just do 1309 minus 295 and you can get the count. But think that when you're working in an actual company, right, the number of columns will be around like thousands, sometimes 10,000s. I'm not joking. There will be lots and lots of columns. There will be hundreds, thousands of columns, and you cannot simply sit and do subtraction for every column. No, you cannot do that. It would be a lot of time consuming. So there are simple ways to do finding the missing values, and I'm going to teach you that. You even if you get a job and if you are working as an ML engineer, you will be using this code to count and sort the missing values. Simple, by using Python we'll be doing it. I already provided the code in the slide as well. See, I will be using similar kind of code. I may not copy paste, but the core thing remains the same. So you take the capital X and we use a method called isNA dot, you will be doing a sum. So what it does, typically it will find all the is null values. If it is true, it will do a sum. So if there are 5 isNA, 5 null values, the sum will be 5. Then usually people stop it here. Usually what others do is they stop here and they go to the next step. But what I suggest is, because you have to code in such a way that when your junior looking at your code, he has to understand what you're doing. So always put comments and always write the code in such a way that your junior also understands it better. So if you leave it here, it doesn't represent anything. What is missing here now? Missing is just a value here, and they won't understand you're talking about which column or what. So always, till now I did not put it here, but from now on I will be putting it. Always add comments. Again, even if you don't put the comments, nothing happens. But you have, as a good programmer, you have to make sure your others also understand your code. So again, dot, I do a sort values, and ascending means small to big. No, let's make it descending. So if you want to do descending, it's simple. Just put ascending to be false. If ascending is false, you will be getting big to small. If it is true, small to big. Print missing of in the array, missing if the missing is greater than 0, or else we don't require it, right? If it is 0, that means that the column doesn't have any null values, and we don't require it. So I'm printing only the columns that has missing values in it. That's why I have put missing greater than 0. It's like an if condition there. Now I print it. Okay, you see, so body is like 1188 data are missing. Cabin, board, home.dest, age, embarked and fare, all of this data is missing, and the highest is body. Okay, the highest is body. Okay, yeah. So we have to do something to uh, uh, correct all of this. But here for the prediction when it is 1188. Okay, let's see. Now we can see the scale of this problem. Cabin, body, home dot desk are mostly empty. Cabin, body, and home dot desk, they are mostly empty. So my suggestion is we will drop it. I'll tell you why. I'll tell you why that I will be doing it. But first of all, you have to understand what these columns mean. That is one thing I forgot to tell you. I forgot to mention. When you're working in a company, right? There will be, and when you're working as an ML engineer or some other field, usually it is the work of data engineers to get the data and to prepare a documentation to represent what each column is. So for example, I'm talking about a very real life scenario. The person who gets the data, he has to submit also a document where the document represents what each particular column is. Like for example, home.dest. Now since I already know about Titanic dataset, I know it is home.destination. But if any new person is looking at the data, right, it feels a bit fizzy, like what each column does. For that, as for this project and as for normal project, just look it up in internet. This is a suggestion I can give. But in a real life scenario, this will not be the case. In a real life scenario, there will be also a document submitted along with the data where you can see and understand what each particular column actually represents. I'm just looking if they have anywhere given what each column does here. I downloaded the Titanic CSV, right? Let's maybe in the dataset they would have provided. Just a guess. No. Right now I usually use AI to get the column, what each column does, but I'm trying to find out in Kaggle if any of them have submitted like what each column does. Okay, yeah. So I got the the information on what each column does from this Kaggle. I'll also share it with you. And yeah, this is the original Kaggle that we are using. I'm sorry, the dataset that we are using, right? The dataset and what you are seeing is here is the same. Survival, P class, sex, age, SIPP, patch, and all. I will also share it with you. Yeah. Okay, so we have a survival column. Wait. I forgot to show you something. I'm always showing you this capital X, but I never showed you what is small y. Let me show you what is small y. Y dot head. Yeah. So y is the survived because our entire project is on this target value. Our entire project is that whether a person is survived or not. So from the dataset, survived becomes the target value. The remaining columns becomes the capital X. So going back, survival column is the actual survival, whether if a person is survived or not. P class represents the ticket class. like in when during train or flight we have different classes of tickets, right? Economy, business, and all. So in that same way, it is P class in the ship, and it is sex is gender, age, our age, and SIBSP is the number of siblings or spouses aboard the Titanic, which are in the Titanic. Patch is the number of parents or children aboard the Titanic. Okay, so SIBSP is the siblings or the spouses of that particular individual person that are in the Titanic. Patch is the parents or children of that individual person in the Titanic. And the ticket number, fare, cabin number, embarked is the port of embarkation. I mean, from which port they have started and all. So here, going back to the code, for whatever the here is where the features come into place. Here is where you have to understand what values you have to consider and what values you should not consider. By looking at the columns and by looking at our use cases, I can simply say that we don't require cabin. Because first of all, there is a lot of missing values in the cabin. There is a lot of missing values in the cabin, and I don't think in a real life situation cabin changes anything. That is my perception. Again, you can argue with it. You can come and say, Monish, how can you think like that? Maybe a person who is in the down cabin of the Titanic has less survival than a person who is in the upper levels of the Titanic. You can argue with it, and the argument is completely valid. But again, this is my own perception, my own ML model, my own thinking. Whatever I feel is right is the model. Again, this is something, there is no universal truth here. Again, I'm saying, for example, I have my child and you have your child. I will teach few things to my child which I believe are true. You will teach some things to your child which you believe are true. I cannot come and tell to you that, hey, I believe this, so you teach your child on what I believe. I cannot simply say that, right? That is not how societies work. So in the similar way, whatever I feel is right is what I will be transferring to the child. The same concept applies here. I personally feel there is a lot of missing data in the cabin. So instead of fixing that, I will be just removing it. That is what my source of truth. That is what how I do. Again, you can do it in different way. You can come and say, Monish, no, I won't delete the cabin column. I will keep it and I'll fix it. You're welcome to do it. And your model will be different. My model will be different. That is where all the ML engineers come into place. This is one more interview question where the interviewer will look at how you analyze things, because ML engineer is not about coding, getting the models and all. Getting the models, coding is the easiest part. If you ask me, it is one of the easiest part on becoming an ML engineer, to actually code the ML models. It doesn't take much time. It takes 5 to 10 minutes to actually write a code in today's time. You get the model, you get the code from ChatGPT or AI, that's all. Your work is done. What is there to do then? Your actual work is to identify the problem, analyze the columns, know what to use, know what to remove. These are the things that makes you an ML engineer, the external aspect. So here I particularly feel cabin is not so important, body is not so important, and I don't even know what body is at this point. Yeah, but it has a lot of missing data, so I don't even want to know. I just want to remove it, because in 1.3 also consider the scale. You have 1309 rows, and from 1309, out of 1309 there are 1188 rows missing. I mean, it's more like 90% of the data is missing. When 90% of data is missing to any column, I don't care how important it is, I remove it. Because if you're trying to fix that 1188, your model will go completely wrong. Like I'll be 100% sure on that. Your model will be going completely wrong if you're trying to fix that 1188. So I don't care how important that column is, I'll remove it. So I remove body because it's more 90% of missing data. I remove cabin, and I also remove home dot destination. I don't think home dot destination matters if a person home dot destination matters on a person's survive thing. Uh, Again, this is again my own my own assumption. It can be wrong. It can be wrong as well. But since most of this is empty, I'm going with these three. Monesh, then why are you not removing boat, Monesh? Why are you not removing this boat? Here, I don't know why this is not given here. Actually, I'll do one thing. Is all of the data given? Class ticket fare. Wait, I'll try to find the exact things. Yeah. So, oh, body identification number. Okay. So body here represents the body identification number if the passenger did not survive and their body was recovered. So what it represents is after I mean I don't want to use certain words, but yeah, after the person is not survived, then we get the body identification number. So for the survival, I don't think, I mean before the survival, I don't think this matters. Again, before the survival, I don't think body identification number matters. Only in the conditions of not survival, we need it. But yeah, I think for the survival, body identification number is not a thing. And home dot destination, hometown or destination passenger, I don't think it's a consideration. And also the cabin numbers also, I think it's not a consideration. But why boat? Monish, why are you saying that you will not be removing the boat? Because boat also has a lot of missing values. It has nearly more than 70% of missing values. But why I'm not removing boat is because think of a situation, think of a real situation. If you are in Titanic, if you are on Titanic, the type of boat that you will be using for the escape entirely depends on the probability of your survival. If you are taking a very good boat, then your survivability increases. If you are taking a very less quality boat, then the survivability decreases. Let's say there is a hole in the boat, the rescue boat that you are taking, your survivability drops down. Let's take you are taking a very high class which has food in it, which has all the escaping things, all of those things in the boat, in the escape boat, your survivability chances suddenly increases. So that is the reason I'm in a conscious level, I'm not removing the boat, but I will be removing body, cabin, and home.destination. And I can also remove fare and embark, which doesn't do much, but their missing values were too low, so I don't touch them. And here age is a middle thing here, because it has 263 missing. There are not lot of missing things here, but there are not few as well. It is acting as a middle ground, but I cannot remove the age in any way. I should not. Two main reasons. One of the main reason is that the missing values are not big to remove it. Second, your entire survivability depends on your age as well. If your age is too low, the survivability decreases. If your age is too high, your survivability decreases. If your age is in the middle of something like not too low or too high, there are higher chances of survivability. So that is why age is the prime factor of finding the survivability here, which I'll be talking later. If you look at all the columns here, the one column that strikes me, that is to be most important in all of them, is the age. If your age is good, there are very high chances of you surviving a incident like Titanic. Even if you take low quality boat, there is a chance, if you're in a right age, prime age, you will be getting out of that problem. So that is why I consider age as one of the highest priority one. So yeah, the same thing even I mentioned here as well. Age 263, 20% missing. Cabin, home, and desktop, I will remove them. Embedded fare are few missing, I won't touch them. So yeah, any doubts still here? Anyone, any doubts, anything? Okay, if no doubts, okay, fine. But if anyone have anything, please let me know again. Okay, so what is the next step, Monish? Let's go to our flow again. Monish, so step 1 is completed, that is getting data into the Colab. Step 2, you will be exploring and inspecting the data. That is also done. We have explored the data, we have found out the missing values of the data, we have inspected the data. If you want to do more, you can do more. No one is stopping you. That is one more thing. I just felt it is done, it is fine. Okay, then I'm going forward. But if not, you can still take your time. The next is selecting the features, but before selecting the actual features, since I know I should not skip those, let me also show you few more things before I go forward about exploring the data, which for you might be useful. So one is describe. Oh yeah, my bad, capital X. Yeah, age.describe will give you the count of the age, mean of the age, standard deviation of the age, mean 25%, 50%, 75%, everything that is related to the age. Okay, so that is what .describe will do. .describe is best used for numerical values. You cannot simply use for string and all. It is used for numerical values. Okay, that is done. Next, I'll show you one more method. These are all useful methods. For you, it may be useful when you're doing data exploration. Instead of .describe, sometimes I usually do counts. What I'm doing wrong? Oh yeah. It's not counts. It's value of counts. Oh, typo. Yeah, value of counts. So Monesh, Why don't you do describe on everything? Why are you doing value counts? Because value counts, what it gives you the value of the categorical thing, right? Describe is used for integers. Value count is used for categorical values. Categorical values. What is categorical values? If you go on to the top, sex is a category. It is a category. So all the values of the column sex will be like male or female. So it is not a numerical value, it is a categorical value. So for categorical values, if you want to get the count, the best way to do it is value of counts. So the same thing you can do for P class, embarked, for any of the categorical values, you can do dot value underscore counts. Great. Now we understand our data. This exploration step before writing any pre-processing code, again I'm saying it is very crucial. If you take more time here to understand the code, it will save a lot of time when you're actually creating the model. So it is very crucial. You cannot handle data correctly if you don't understand what's in it. So take more time in this step 2. So the next. Actually, there is also missing values part before going to choose features. Yeah, okay. Let's pause the coding for a moment. I know, and there is only one more minute for the break. Before going to the break and before doing for the next exploration, the features thing, just pause for a minute and talk about missing values conceptually, because the strategy here matters. Let's go to a bit of concept. Give me few minutes of time, like three to 4 minutes, and we'll take a break, because whatever I'm gonna teach now it will be so important. I'll be teaching you 3 common types of missingness. 3 common types. 3 types in missingness of the data. First one, again, this can be an interview question. They'll simply ask you what are the 3 types of missingness, and the 3 types are MCAR, MAR, MNAR. So I'll write them down. One is MCAR. So what is this MCR? MCR stands for missing completely at random. Missing completely at random. Yeah, missing completely at random. So what is this missing completely at random thing? The missingness has nothing to do with the data itself. Like if a data entry person randomly skipped some rows, then it says it is a missing completely at random. In Titanic, in the dataset of Titanic, what I observed, I mean, I took my time. Since this is a 3-hour class, I cannot show you the entire dataset, take every minute and all. But I already worked on the dataset in the past, and I've seen this data closely for a while. Embarked is a particular column in this particular Titanic dataset, where the rows are missed so randomly, like just a few records where the port wasn't recorded. And this is a classical example of missing completely at random. So you will have one row, you will have a second row, suddenly third row will be missing, fourth row you will have a row, you will have the data, fifth row will be missing. So randomly, without any particular sequence, how do I say, if it is so random and it feels like because of some error it happened, then it is a MCR, missing completely at random. The second is MAR. MAR stands for missing at random. Monash, what is the difference? Missing at random. Again, before talking about the example or the difference, you have to think in a real life situation. Again and again I'm saying, since this is a Titanic dataset, you have to think it as a Titanic data engineer. If it is something like COVID dataset, you have to think like a COVID data engineer. You have to think of the real life scenarios. Again, you have to take human emotions into consideration. You have to take into real life events into consideration. You have to think about news. You have to follow the news about the ongoing things and all, because all the data that you will be handling are real life incidents. They are real life data. They are not something imaginary, right? They will always be real life data, so you have to take humans into consideration. So the first thing, MCR, I told you an example where some people, maybe during the data entry into the data set, something has gone wrong, and the data engineer forgot to enter something because it was so random, and the port of entry was missing because of some reason or a technical glitch. The second, missing at random, is like the missingness is related to other columns. The missingness is related to other columns, not the missing column itself. Here the example will be, when I looked at the data set, when I looked at the entire data set of Titanic, the age is something that struck me. Why? Because the people who has taken uh, the best ticket, it is related to the P class. The people who has taken the best ticket in the Titanic, like the top class tickets, which are the wealthy people, they didn't give their age. So here, taking into human emotional considerations, what I understood is, wealthy passengers had their ages recorded more carefully than the third class passengers. In the sense, wealthy women or wealthy men, they did not want to give their age. They did not want to tell their age recorded. So they just bypassed it. They just did not enter their age into the form. That is what I understood when looking at the data in a bigger perspective, when I've seen and categorized the ages into P class, embarked, boat and all. One of the thing that I found out is, wealthy people, they do not want to give their ages recorded. So that is missing at random. Here it is not a technical glitch. Here it is not a person not entering the data at random, nothing like that. It is missing at random, where the data that is being missed is because of some other column. It is dependent on some other column. So if the person is rich, he or she did not want to record their age. So this is a classic example of missing at random, MAR. Third, MNAR, missing not at random. Here you will see a particular pattern, missing not at random. So the missingness is related to the value itself. Here the missingness is not related to the other column, it is related to the value itself. For body in Titanic, for the body, where is that body? Yeah. For the body column in Titanic, it's missing because the body was not recovered. The body was not recovered, which correlates with the survival outcome. That is MNAR. Here, in suppose, when the body is not recovered, you cannot say that the person is alive or dead. You cannot simply say that. If you did not find the body, that doesn't mean the person is dead or the person is alive. You still did not find it. That's all. So there are chances again on that particular data, and here the missingness is related to the value itself, because again I'm saying it's missing because the body was not recovered, which correlates with the survival outcome. That's MNAR. Why does this matter? Because the type of missingness, I mean Monesh, all these three feels similar to each other. Then why are we learning this, Monesh? It matters because the type of missingness should influence your imputation strategy. If the values are MNAR, you might want to add an is missing indicator column alongside the imputed values. So the model can use the pattern of missingness as a signal. So for today's class, I mean today's project, we will be doing a lot of projects. We will be doing a project tomorrow in the next class also. In this project, we will use a standard implementation. We'll use something called not implementation, standard imputation. Imputation means fixing the values, fixing the missing values. We use the standard imputation because our goal is to learn the pipeline pattern. Here our end goal is to teach you an entire flow, because only teaching the missing values will take a good amount of time. Like example, it may take around 4 to 5 classes easily. There are a lot of imputations, there are a lot of methods, there are a lot of algorithms to fix the missing values. But we will use a standard imputation because our goal is to learn the pipeline pattern. In a real project, you would spend more time analyzing the missingness mechanism, because how the things work is you may learn 100 ways to fix the missing values, but in the job you will use only one or two. That's all. So I don't suggest to read all the ways you can do the imputations. A basic imputation will be more than good for in a real life situation. So any doubts before going for the break? Any doubts anyone in the MCR, MAR and MNAR? MCR is because of a technical glitch or a person randomly missing some values. MAR missing values because of some other column. MNAR missing values because of its own column. Any doubts till here, anyone? Okay, but if anyone have any doubts, please let me know. Yeah, let's go. Let's take a break. Let's take a 20-minute break. It's 4:40, right? So let's meet back in 20 minutes. 5 p.m. CST. Yeah. Yeah, let's meet back after 20 minutes. And then we'll continue. Hello, hello. So yeah, we are back after the break. Let's continue where we have stopped. So after all the exploration part get completed, now let's pick our features. In a production project, you do a more thorough feature selection analysis. For today, we will use a well-known subset that's information and manageable. So since we already explored the data, here some of the important data columns that I have found is age, numeric, which tells us if they are young or old, fair, which tells again it's a numeric, which tells the proxy for socio-economic status. I mean whether what kind of fare they have paid, what kind of socio-economic status they had. Because if you think of a situation in a Titanic, usually the wealthier has more chances of getting the better boats, has the more chances of getting the better emergency exits and all. So fare acts as a important aspect here. Coming to categorical variables, I have chosen sex, historically one of the strongest predictors in any survival prediction. So that is one of the column I have picked. Embarked, again it is categorical, but here the port of embarkation, like I think it has three categories, like Cherbourg, Queenstown, and Southampton. Here, why again I'm choosing embarked is because if the Titanic being hit, the incident happened before uh, Queenstown, then the chances of survivability of the people who are being embarked in Queenstown are, they're like 100%. They are all survived because the ship even hasn't reached it there. So I took embarked as one of the categorical variable, and and also the P class. P class is where the passenger class, the first class, second class, and the third class, that is related to the fare. And finally the target that we are trying to predict is survived, whether a person, whether is an individual, survived or not survived. So these are the features I have picked for the model. Again, you can argue with me, like any other columns also can be used, but again it's a personal choice. You can use some other features, I can use some other features, our models will be different, and we can look at the accuracies. Actually this is one of the point in model tuning as well. So yeah, let's code it first. So I've taken the numerical features and the categorical features and doing a subset our features, feature matrix to just these columns. It's on. So I'm just creating a separate subset called X of Titanic with the important features that I've just talked about. It's like a subarray. Let's take head of 10. Yeah. So here what I've done, I've created a sub array of columns like with age, fare, sex, embarked, and P class, and these are the first 10 rows of that particular data. So here what I've done is called features, the feature identification. That is the step 3. So I've identified the best columns from the model, and I have created only that particular subset, so that I will be working only on that particular features. Notice here, if you notice, oh, I forgot to add it. I have to add dot copy. Then do, yeah. So if you notice, I'm calling with dot copy here, right? That's a Pandas best practice. It creates a new data frame instead of a view of the original. This avoids confusing settling with copy warning errors later. Because here what happens is, if I don't use this copy, dot copy, whatever the changes that I do here will be also affecting the original data. But if I do dot copy, whatever the changes I do in this particular X Titanic shape, Titanic, it won't be reflecting to the original one. So always use dot copy when you are doing a subcategory or feature matrix, identifying the feature columns, so that whatever you do won't affect the original data. And let's find the missingness in one column. Yeah, so the missing values here are age 263, fair, sex, embodied, and p class. So only age is the problem here, but still age is an important aspect. And even though p class, one more as a note, p class is stored as a string here, 1, 2, and 3 in the dataset. They are not numbers. If you look at p class, you may think that they are numbers, but not. They are categorical values. Here 1 represents something, 2 represents something, 3 represents something. These look like numbers, but they represent categories, not a numerical scale. So we will treat as categorical and one hot encode in it. So one here, all the ones that you see are not numbers; they are strings. They are categorical values. They represent something. One means first class, first class in the boat, second class in the boat, third class in the boat. In that way. Okay. Next. Train, test, and split. I already talked a lot about train, test, and split in the previous class, so I'm not going to talk about it right now. But do anyone have any doubt in train, test, split? Let me know. Like I already said, what is train data, what is test data, how do we split it, what is the 0.2 test size, what is the random state, what is satisfy. Stratify is nothing but the value of uh, this value, the targeted value. The targeted column will be a stratify, but it's an optional thing. You can remove it. But any doubts in the train and test split, let me know. The only new thing that I have added stratify is because the survival ratio, the prediction ratio in the training data will match the test data, which makes a model bit better. That's why I have added stratify parameter there. But if you want, you can remove it. It's just an optional thing that I thought of in the last minute to add, just to make the model better. It holds the ratio. If in the training data there are 3 failures, in test data also there will be 3 failures in that way. Any doubts, anyone in train and test? Only because I've covered a lot about it in the previous class, I'm not talking about it right now, just to save us some time. But if anyone wants me to talk about it, please let me know. And if any doubts, also let me know on train and test. So train and test data, we are splitting it into 80-20, just like before, and we'll be continuing with it. So for that, instead of writing the code, I'm just copy pasting it again, because this is the same code that I've used in the project, in the last class project. Okay. Ha. Okay. So our training data, if you see, has a lot of missing values. Our training data. So we will be handling those missing values. Uh, let's check how much data is missing in the train that we have taken. Huh. Still, age has 209 missing values in train. I'm not talking about the overall data. Only in the training data, there are 209 missing data from age column. So uh, here, let's talk about our imputation choices. For numeric columns like age and fair, we will use the median, not the mean. Median is different, mean is different. Why? Because fair can have extreme outliers. A first class suit costs many times a third class ticket. A third class ticket, let's say it is $30. First class ticket can be $200. We don't know. So it is a big outlier. The mean would be pulled toward those high values. So for things like fair, right? Fair has an extreme outlier, so we take median. Median will be more robust here. For categorical columns, I mean there are no categorical columns null values here, but as an example, for categorical columns like sex, embarked and p class, we will fill it with a constant, the string missing. We'll just put the string missing there. This is better than using the most frequent value because it preserves the information that some passengers have no recorded embarkation port. The model can learn that missing has its own pattern. So instead of putting some value, just put the word missing into that categorical column. But here categorical column don't have any missing values, so that would be fine. So here we have to correct the age. In scikit-learn, we can use a SimpleImputer for this, and the function also it is called a SimpleImputer. I told you, right? I will teach you one SimpleImputer for missing values. This is about it. Dot import SimpleImputer, import numpy as np, numImputer equal to SimpleImputer missing values okay. Here I want to tell you something. In Google Colab or anywhere, whenever you're writing something, AI will assist you. AI will give you some completions, auto completions. But as a good ML engineer, you have to understand whether those values are right or wrong. In this case, this is wrong. I remove it. And I simply say strategy equal to median, because what I said, I'll be using median because the people who are boarding the Titanic can be a 1-year-old baby and can be an 80-year-old man or a woman. So the age differences are huge. It can be huge, is what I'm saying. So if you use mean, right, if the old people are more, the mean will be going towards them. So that's why I use median for these kind of issues. numImputer.fit. So what it does, wherever there is a null value, it will be replacing that null value with the median of the overall data. X underscore train of age. Imported to transform. No. So here print learned median from age, num of imputer num underscore imputer dot statistics. Let's run this. Strategy is wrong. Okay, it's a typo. It's strategy. Yeah. And here, what's the problem? The imputer. Okay, it's imputer. Yeah. So here we got a value like learned median from age is 28. So the entire median, I mean the average value of the age of the people onboarding the Titanic is 28. That's what we understood. Next. Again, Monish, what is this dot statistics? Here I said strategy equal to median, right? When I said dot statistics, it will just calculate the entire columns median. If I say mean, it will calculate mean. If it's median, it will calculate median. Simple. Now I have to transform both train and test using train fitted algorithm or train fitted imputer. So simply it will go over all the train data of the age, and wherever it finds the null value, it will be replaced with the median. That's all, simple. So age train imputed equal to num imputed dot transform x of x underscore train age, and the same for test. Yep, this is good. Now finally print missing in age after imputation train PD means pandas PD dot is null age train imputed dot sum. Incomplete input imputed dot sum. Now you see, after the replaced values, the missing values in age is 0, and the missing values in test in age inside the test are also 0. So what we have done, we have successfully corrected all the missing values inside the age column. Notice this pattern here, dot fit on train. Whenever I'm doing with train, I used dot fit, and whenever I'm using on train and test together, I was using transform. This transform. Never do dot fit on test. This is again one more interview question. You can use dot fit only on train. If you want to do some operation on both training and testing, never ever do dot fit on test. Don't do it. Don't use dot fit on test. It's like you giving the answers to the student in the mock exam. Don't do that. You can only do dot fit in train data. If you want to do something to the train and the test together, then use transform, dot transform. So transform for train and test, dot train is only for training, dot fit is only for training data. Remember that part. So here that's why I used train fit, train and test for transform. So yeah, any doubts still here? We have successfully completed the missing values thing. This is completed, right? Simple, yeah. So before writing, before moving to the next step and writing the sorry. Any doubts, anyone?
Yeah, Manish,
Yeah.
quick question. So why should you not do fit on the test?
So if you do fit on the test, right, you are indirectly giving the prediction values also to the test data. It's like a student studying for the mock exam, and you, as an invigilator, we are providing the answers to them.
No, but here we have done the fit on train,
Fit on a
and
train, yeah.
yeah, and when we did the transform, basically, isn't it we copied the same into test?
When we do fit on train,
And then we did the transform, right?
yeah.
So isn't it like we copied the fitted data into test? That's why your missing age is 0 in both train and test.
Uh, Maybe I did not get the question properly. So here I'm using the SimpleImputer to find the median,
Correct.
and then I use the dot fit on the train.
So basically, when you say dot fit, it's on the train data set, you have fitted the age column,
Yeah,
right?
correct.
Okay. Now, what does transform do here?
So
So when you
fit
say age train imputed, so what does transform did? Did it copy that age into that train?
fit is used to learn a parameter from data. It
Mhm.
understands what the age, the numbers, and all. Transform is to apply that learned rule. Like in fit we don't perform an operation, rather the model only just learns it only the learning part happens, but the applying part doesn't happen in the fit. If in transform the apply part happens, the learning part doesn't happen.
Okay, only the apply part happens.
Yeah, transform is used to only apply the operations.
Okay, understood.
So that's the reason we cannot do fit on a test, because fit is only used to learn the pattern. We only do the learning before the mock exam. During in the training phase. In the test, you should not do the training. You should not
Yeah.
fit the. Yeah, you should not do any fit.
Okay, got it. Thank
Yeah.
you.
If I have to put it in a line, uh,
Monish, I have a
yeah,
question.
yeah.
What's the difference? Let's take we know that there are values that are missing and we put the median values wherever the NaN values are there. What's the difference of just appending the like median value and using the fit function?
The fit function will not put the median into the edge.
Okay.
It will not put it will just understand wherever the values are missing, and it will just puts it into the memory kind of thing, but it will not apply. Even after this, if after this particular line, even if I
Mhm.
find the number of missing values, it will still be 209.
Okay.
In transform only, that values will be replaced. The actual operation happens in the transform.
Any particular reason why we have to like go two steps, like understanding and then transforming? But what if I just say that like wherever I have the NaN values, replace that with the median values?
uh, Here one thing is, I never set the transform to you, like the nans or anything like that. If you see,
Okay.
I never said where they are empty.
Okay, okay.
Where they are empty and how, I mean, what are the values in those empty values, how where they are empty are all understood in this dot fit.
Okay. Okay, okay. Thank you.
Yeah. To make it more simple, how would I put this? Calling fit on the test makes your pre-processing learn from the test data, which breaks the whole point of having a truly unseen test set. Because when we use dot fit, right, automatically the test data will be able to see your target column, which we don't want to happen. So dot fit should not be performed on test data, and that leads to a data leakage or a biased evaluation problem. Yeah, that, if I'm right, yes. And fit will only learn from the model, like how the null values are being there in the column, where the null values are present, and it just understands the parameter from the data, and it knows that we are going to put median, but it will not apply it. No operations will be performed in the fit. Even in the model.fit also, in the later, when we do the model, I'll show you something called model.fit. Even in there, no operation will be performed, only learning happens there. Dot fit represents learning, dot transform represents applying or operations. Transform is for operations, fit is for learning. So basically, let me put in whiteboard. So here it will understand that there are NaN values in the train data. In this line, the imputer, the imputer algorithm that we are using. I don't call it algorithm; it's an imputation. But yeah, we can also call an algorithm. That algorithm understands. Okay, there are NaN values inside the train, and how they are. What is the pattern in it? That is all is understood in this dot fit. NumImputer dot fit. In the age train imputed, this is where it will replace. The actual replace happens here. It replaces this NaN with the median value. If you you can ask a question like, why are we using fit then? I mean, simply you cannot use fit and directly use this thing. If you don't use this line, the NumImputer will never know how the null values look like, how the nulls are in the column. Null values are usually NaN, but where they are, how they are represented, that will never know by NumImputer. So it's a very good practice to always use dot fit first, then it will get a good understanding of the nulls, and then we use the transform to make the operations on that particular missing values. Just trying to make it more clear.
So, I mean, I didn't want to waste time here, but quick question is, when you go to the test, right? We are using the same transform, so we are saying we are giving the answers to the test. We are not giving how to derive those answers, the logic which is in the fit, but the answers we are already giving to the test. What should be the answer? You understand what I'm saying? Because when we do the transform on the test also, applying it with the age, the missing values with some 28 with the median.
Yes. Yeah, we are giving it, but we are not giving the surveyed data.
Correct.
In dot fit, it reads everything. In transform, it don't read. It won't read the other columns.
Okay. Okay.
And I think I can actually show you if I comment this out, and if I run it, it's already 0. But yeah, this also won't work. Yeah. So this is if you skip the dot fit, if we skip the dot fit, and if we call the transform directly on a scikit-learn transformer like SimpleImputer algorithm, it will fail with a not fitted error. Where is it? Yeah, it will fail with a not fitted error, which indirectly tells you that because there are no learned parameters like the median stored yet, without understanding the actual patterns, actual parameters, the algorithm cannot be applied on the column. That is how transformers work. Like, they first need to understand the entire data, then they start to applying the missing values.
Okay. Understood.
Yeah. So simply again, or else I'll try to make it much more simpler. Here the median gets calculated. Without this line, the median won't be calculated at all because it's not even learning. The median won't be calculated, and that median cannot be applied here. Only if you give this value, it will start to do dot fit on the train. The value will be, the median value will be calculated, and you will be getting the value. The problem if I use Y train, that is the testing data, is test data is very small, that is 20% of the actual data. If you are calculating median on the 20% of the data, your calculation goes wrong, right? You calculating the median on 80% of the data is different, you calculating the median on 20% of the data is different. So this will not yield good results in the first place. But if I run it, what is the median before? Let's see the median of train. The median of the train is 28. Now let's do for the test. Oh, first of all, it's not allowing on Y train. Yeah, you can see here, I'm doing correct, right? It's Y test or X test, sorry, X test. Yeah, it is 29, but you use the difference 28 and 29 will do a lot of impact on the model, and since it is a 1309 columns, it is fine that you got a 28 and 29 age medians when using on train data and test data. But if you are working on a very big data, right, this simple difference can also make a lot of impact on the model. And yeah, this is one reason to not use it on test. Test itself, the percentage of test is low, that is only 20%, and also there will be a problem of like what I said earlier, data leakage in evaluation.
Yeah. Understood.
Yeah. Okay, so please. Yeah, and please ask questions like this. Otherwise, yeah, others also wouldn't have understood this, like why we use only train and not test, and what happens if we don't use it and all. Yeah, please ask these kind of questions. And thanks for that. Where did I stop here? Yeah. So before writing the full pipeline code, let me lay out the complete pre-processing plan. So we all were on the same page. So for numeric features, I have used a SimpleImputer with a strategy median, and I'll be also using a standard scalar for scaling. I mean, in the code I'll be doing all of this. This is just a plan on what I will be doing. For categorical features like sex, embarked, and p class, I will be imputing the constants with a fill missing, with a missing string into those wherever there are missing values in those columns. And I also do something called OneHotEncoder. OneHotEncoder is again one functionality that we have with categorical paths, where numbers represent something. Like for example, in P class, there are values like 1, 2, and 3. 1 represents something, 2 represents something, 3 represents something. We will be doing OneHotEncoder to map those somethings. You cannot use 1 as a string moving forward. You have to change it to something like a string or something. So there we'll be using OneHotEncoders. And why do we use scales? Why do we scale numerics? Because many models, including logistic regression and neural networks, are very sensitive to the scale of inputs. For example, if a fare, the column fare that I have seen, if fare ranges from 0 to 500, but age ranges from 0 to 80, the model might give disproportional weight to fare column, just because the numbers are bigger. This standard scaler concept is something that many ML engineers, they don't look at it. They just overlook it. They find the missing values and they move forward. They go to the next one. But you have to also see the numerical values scale, whether from where it started, I mean the minimum and maximum values of any column, of any numerical column. Age is from 0 to 80 maximum, but the fare goes from 0 to 500. If you don't do this standard scalar thing right, the model will give the disproportional weight to the fare, and it means that it will give you more advantage to the fare, and makes the numbers are bigger. So the standard scale normalizes both to mean 0, standard deviation 1. And I mean, the standard scaler will put the age and the fare in a linear scale, in an equal balance, so that the model will understand it perfectly. If the balance is not there, the model will think that age has less weight, and I mean age is less important and fare is more important. So to make them balanced, we use standard scaler. I'll be using that in the code. And why do we use this OneHotEncoder? I hope you understood SimpleImputer. SimpleImputers are used for missing values. Standard scaler I've just explained now. OneHotEncoder is to models understand numbers. Simple. That is simple. Model understands numbers, not text. OneHotEncoding converts sex into 2 binary columns. So for example, right now in our data, sex represents male or female. We as a human, we understand what is a male, we understand what is a female, but the model will not understand it. Model only likes numbers. It only understands numbers, not strings. So to convert these kind of categorical values into mapping some number, we use OneHotEncoding. So this male and female is there, right? Maybe we can give female to be 1, male to be 0, or male to be 1 or female to be 0. Anything is fine. Here you have p class 1, 1s, 2s and 3s, right? Here 1, 2s and 3s are not actually numbers, they are strings. In the beginning also I said they are strings. So you have to convert these strings into some numbers. You have to map it to some number. So this is called OneHotEncoding.
Monish, I have a
Yeah.
question.
Yeah.
So what happens if there is another gender? Let's take if not just female and male, they have not assigned any gender, and then it's, what do we do at that case? Can we still use the OneHotEncoder, or
You mean like any third gender?
any third gender is added in there.
Then we will be having 3 numbers, 1, 2 and 3. 1 represents
Okay.
maybe female, 2 male, 3 third
Okay.
gender.
So you can still use that function, OneHotEncoder. You can still use that function to assign it there.
Yeah, yes. Any number of categorical values, it will be fine. You can just
Okay.
assign numbers like 1,
Oh,
2, 3,
it's
4,
not
5.
just like the Boolean 0 or 1.
No, no,
So
no.
it can be okay.
Here in P class, there will be 3 values. I mean, I looked at the data. In P class, there will be 3. 1, 2, first class, second class, and third class. So we'll be assigning something like 0, 1, 2, or 1, 2, 3, something like that. Yeah. Okay. So before going into this pipeline thing, any doubts on what we will be doing? SimpleImputer is for handling missing values. StandardScaler is to put the fare and the age in the same balanced thing, balanced scale, so that the model will understand both are important. Like only fare is more important than age, it will not think like that. To think both are important, we use StandardScaler. OneHotEncoder is to convert the categorical string values into numericals. These are the things we will be doing moving forward. This is the processing plan, pre-processing plan. Yeah, since you already know what to do, since you have planned perfectly, the code becomes easier. You simply say imputer, scalar, imputer, OneHot. That's all. The functions are that simple. That is why from the beginning I'm saying coding is never a problem in ML. You can simply if you know the plan, if you have an exact plan, coding becomes very simple. The methods, the functions are so simple in ML to remember. If for imputer you use imputer, for scalar you use scalar, and the functions also SimpleImputer, StandardScaler, SimpleImputer, OneHotEncoder, and you give parameters whichever you like, and that thing's the things done. Let's code. Since we again I'm saying, since you already have plan, it is becoming easier. If you don't have a plan and if you don't know what to do with the data, then the real problem comes in. From scikit-learn dot pipeline import pipeline. Okay, Monish, what is this pipeline thing? The concept of pipeline is that, let's take few boxes. How a pipeline works is, I will give the first input to the first box. The first box output will be the second box input. Okay, this is IO, that is input. This is output. Let's say input, output, and this first box output will be the input of second box, and the second box output will be the input of the third box, and finally you will get an output. This kind of mechanism, this kinds of concept you will be seeing in conveyor belt systems. When you are creating a product, or in factories where the things are made, you will be seeing this. Like one robot will be packaging the entire thing. One robot will be maybe arranging in proper order. One robot will be doing something. So after we do something, it gives to the next one. It does something, it gives to the next one. So that is what a pipeline means. This concept is called pipeline. Pipelines, and it can be one or many. Again, this is a thing to note. You don't need to have only 3 boxes or 2 boxes or 1 boxes like that. You can also have 1 box. It's fine. You can also have 1 box. You take an input, you perform some operation, and you get an output. This is also called a pipeline. Pipeline is something that takes an input, does something, gives to the next one. That's all. That is a pipeline. It starts, it ends, it has a flow. Anything that has a flow, conceptualize, it is a pipeline. So here I will be creating a pipeline. Why? I'll tell you. From scikit-learn pre-processing, I import StandardScaler, and also we will be using OneHotEncoder. You see, every concept has a method. This is one more beautiful thing about machine learning. You no need to write all the functions and all. Every concept that you learn will have a method. You will be just using that method. So what I'm going to teach you is I'm going to teach you how to create a pipeline. We are not actually changing anything. I'll show you the difference. Numeric pipeline, impute, then scale. Numeric transformer equal to pipeline. Pipeline, the steps would be, so pipeline method has a parameter called steps. So the steps would be equal to the first step, imputer, SimpleImputer, strategies, median, scaler, StandardScaler. There, this is correct. Again, you see, I'm not entirely depending on AI. You have to, I want you all to also do the same. Use AI whenever it is giving an auto completion. First look at it. If it is useful, then use it. If it is not, then don't use it. Because sometimes it will give you errors also, which you don't require. You have to check that. Categorical pipeline.
Numeric transformer spelled incorrect.
So, sorry?
Numeric transformer, the spelling.
Oh yeah, correct. Thanks. Yeah. Thanks for that. No. Here we first, we don't call impute for categorical. We say fill missing. Fill missing. After fill missing, we do OneHotEncode. OneHotEncode. Okay, categorical transformer, pipeline steps, imputer, SimpleImputer. Strategy is constant, fill value is missing, correct. OneHotEncoder, handle unknown, ignore, correct. Why is there an error here? Pipeline starts here, ends here, starts here, ends here. Sorry, goes here. Correct only, yeah. It's not closed. Yep. Starts here, ends here, starts here. That's odd. Okay, I'm not sure why it's throwing an error, but the opening and closing tags match. So I just run it. Oh, okay.
Strategy. Yeah.
But yeah, it worked. I without knowing, I have added this symbol here, which created a problem, a typo. Oh, so yeah, sorry, someone is asking. So here the strategy is median, where we'll be calculating the median of the entire column of the of that particular column, and we'll be using it as our strategy for replacing the values. Here we are using constant for the strings, where we will be replacing it with missing. These are for categorical, these are for numerical. So let me explain what this handle unknown equal to ignore in OneHotEncoder does. This means if the test set contains a category value that wasn't in the training set, don't crash. It says that if you have a value which is in the test set but it is not in the training set, if you don't say this ignore, right, if you don't say this ignore, your pipeline won't work. It will simply crash. It doesn't know what to do. But if you put handle unknown equal to ignore, it won't crash. It just outputs all zeros for that column. This using handle unknown equal to ignore will is an important for robustness in real products, in real jobs. You may get a new category values after deployment, after you deploying the test set and all. You may get a new categorical value if you don't use this handle unknown equal to ignore, right? I have seen in personally, I have seen a lot of pipelines after going to deployment also break because of not using this parameter handle unknown equal to ignore. If there are any values that are not matching in the test data and the train data, it simply says don't do anything, just continue with what you are doing, don't think more about it. Is what this handle unknown equal to ignore does. If handle unknown equal to ignore is not given, if you don't give this, then if there is any mismatch in the train data or test data, any categorical mismatch, it will immediately break the entire flow. It will immediately end the pipeline. So we don't want it to happen because the values may change in the real life. So it's always better to use handle unknown equal to ignore in OneHotCode encoder. And these two pipelines are just the definitions here. If you look at it carefully, I have never given X train, Y train, Titanic data, this data, that data. I have never given anywhere. If you see from top to bottom, the two pipelines are just the definitions right now. We haven't applied them to any data yet. Think of them as recipes. If you give me a numeric data, I will be doing numeric pipeline. If you give me a categorical data, I will do the categorical pipeline. I've just created the pipelines but have not done anything with it. It's just definitions, and we have done nothing. So let's, as a good practice, it's a very simple definition and we know that it will work. I know it will work. But as a very good developer or ML engineer, it's a very good practice to first test your pipeline before applying to the actual data. First and always you have to test your pipelines. Maunesh, how do we test our pipelines? Simply, we will be creating a test set. This test set what I'm talking is different from the training and the test data of Titanic data. That test is different. This test is just to test this flow, this pipeline. Small test data I will create. Quick test on. Let's do it on numeric transformer. It's easy. Test of age equal to x. Or else instead of dummy data, I mean in real life scenarios you create a dummy data and do it, but since again only few minutes left, I'll just do a test on small slice, small data. Okay, in Xtrain I'll take the first 10 and I will do the test. But usually for you, when you have time, do it on a dummy data, create a dummy array and then you do it. But I just looked at the time now, we don't have much, so I'll do it on the first 10 slice, a small 10, first 10 of the data. Xtrain age dot head of 10. So first 10 rows will be going to this test of age. Print before, oh my god, print before test age dot to string test age to string. Again, Monish, why are you doing suddenly to string? I just want to print out, that's all. Just for printing purposes, I'm doing test age dot to string, but I'm not converting anything. Just for the testing purpose. Actually, I no need to use to string also, but I have a habit whenever I'm printing numericals, right? I usually convert to string. Because in this Google Colab it is fine, but in the AWS environments and all, in the real life work, it will throw some errors. So it's a habitual thing. Result equals to numeric transformer dot fit transform of test age print after. Here see, I'm using the auto completion, but I know what I want, so I don't want the pd.data frame. I remove it and I just need the result. That would be fine. And here after imputed plus scaled. Why I'm writing here imputed plus scaled is because when I call numeric transformer, automatically it will do, it is a pipeline. It's not a it's not a single method, it's a pipeline. So when I call numerical transformer, what happens is it will first do the imputation, like it will find the missing values and it will fill those missing values. Then automatically it will apply the standard scaler on those particular column. It will apply the standard scaler on the column to make the entire scale in a good manner for the model to understand. So automatically these two methods will be performed on this particular data that we are giving. That is why I call it as a pipeline. Without pipeline, you have to write two methods, two functions separately to call both of them. But here what happens when I say pipeline, each individual step automatically performs. It's like automation. We are doing a simple kind of automation here. Now if I run this, yeah, you can see here we got the first data. There are NaNs in it. Those NaNs are what do we call those NaNs are replaced with some values which I don't know. They are replaced with some values, and if you see the data, you see this data and you see this data that you have here. Here the data is NaN 24, 11, 25, 16, 25, 25, 20, NaN. But if you see here, it is completely different. It is 0.487, 0.487, minus 2.39, 0.70, minus 1.28, 0.70. Some data which you cannot understand. Suddenly it has changed, right? This is scaling. Here the values are now standardized, centered around 0. A value of 0 means exactly the median age. I don't have the 0 here, but if I have the 0 means the median age. Positive means older than median, negative means younger. This is how we send it to the model. This is the right way to send to a model. This is the right way to send a numerical data to the model. What usually all the ML engineers in the beginning like they do is they send this 24, 11, 25, 16, 25, 25, 20 to the model, which will confuse the model, which will not give you the right values in the outcome. You should always scale the data and send it. if you scale the data and send it, the output will be much better, because the model first of all understands the data in a more better manner than what we send in 2411 and 25. So this is the right way to send a numerical data to the model training. Still we did not go to model training.
First column, Manish, here before. First column is the row number.
First, yeah,
999
ID.
ID. Okay.
First column here is the ID, this is the age. And here I am printing only the age.
Oh.
So yeah, this is how we send a numerical data. Both imputed means replacing the missing values. Scaled means scaling the numbers in a way around the median so that the model can understand it much better than the normal values. Okay, I think I'll stop here. Still there are 8 more slides left, but yeah, I'll continue this in the next class. Yeah, so any doubts in the entire class, you can ask me. And I hope whatever I've shared already got updated, so you can use this link and you can explore with, you can do experiments with the code. Don't change in here. I think you don't have editor access, I guess. View, yeah. You can take a copy of it and you can do experiments with it. Like experiment what happens if it is 0.8 instead of 0.2. What happens if instead of using age and fair, try to use a different column and see what happens. The values will change, but see experiment what happens here and there. How many missing values for here, how many missing values for there. So you can play with the data. The more you play with the data, more you understand the data. So yeah, any doubts, anyone? If you have any doubts now, please let me know. If not, also you're free to message me anytime. Maybe you can see the recording of this, and suddenly in the night, if you get a doubt, you can message to me. The moment I get available, I'll reply back to you. So yeah, before closing, any doubts, anyone on this?
Punish,
Yeah.
I have a question from the last week. There was something that you gave us, like what to do after the class. And do we upload that into our dashboard, or is it something for us to practice that you gave us?
Upload it, whatever the work you do, upload it to your GitHub. GitHub
Okay.
or you know about Hugging Face, right, Komla?
Yes,
Yeah.
yes, yes.
Yeah, upload it to Hugging
Okay.
Face as well.
Okay. Yeah. No,
Yeah.
I was thinking like where if it's on the dashboard or anything. But yeah, definitely
Yeah.
I'll upload. Thank you.
Yeah. Yes. So any doubts, anyone? Yep. So that's all for today's class then. We'll meet back in the next class, and I'll also send this presentation. We have covered till only 12. 12 to 20 we'll cover it in the next class, so no worries. I'll share this PPT presentation as well. So yeah, stop the presentation. Love you all then. Take care. See you all in the next class. Any doubts, please feel free to ask me. Yeah. Love you all. Take care. Bye. See you.
Thank you.